Hello, welcome back to Basic Biomechanics Tutoring. My name is Chandler McDonald, and today we are going to be continuing our series with torques and levers, but now looking at reaction boards, something used to determine center of gravity. We'll get to see a little bit about center of gravity, determining center of gravity or center of mass of a person using a reaction board. So let's take a look. Here is our series for today. In the previous videos, we discussed these three things. We're going to talk about center of gravity and reaction board. Okay. Let's scroll past this old stuff, and here we are. So a 5'2" woman, measured to be 120 pounds, lies on a reaction board that's 7 feet long. The force plate data measures a reaction force of 61 pounds. If the reaction board weighs 25 pounds, what is the woman's center of gravity? Okay, let's move on. But first, it helps to know what a reaction board is. Otherwise, good luck solving the problem. And basically, on the next little page is kind of a diagram what a reaction board is. So you have your knowns on the left, the weight of the woman, the weight of the board, length of the board, and this reaction force. We're trying to find the center of gravity of the woman. So essentially, this is what a reaction board is. You have some sort of board. On one end, there's a force plate. There can also be like some other force here. But here is where this reaction force is going to be located. This force reaction measured by the plate. Okay. This is going to be your axis of rotation here. We're dealing with torques and levers again. Well, mainly torques. So the weight of the individual is going to be from their center of mass coming down here. Then you have the weight of the board coming from the center of the board, assuming it's built nicely. Center of the board here. This is going to be the distance of center of gravity here. You also have distance to the board here, which is basically the length divided by 2, and you have the full length of the board. So here we go. We have all the information we need to move forward with this, to finding the center of gravity of the woman. So let's go ahead and do that. But let's, as we normally do, let's simplify the picture a little bit in order to help us understand direction, and then we can go about solving for the torques, finding the unknowns, and so on and so forth. So let's do that. Essentially, you have this axis of rotation here. You have the total length of the board here. You have a reaction force measured here. The person is going to be laying on the board. Just draw a little stick figure like that. Center of mass coming down this way. Weight of the board this way. So let's talk about directions of rotation. If we have this reaction force here, it's going to cause a rotation this way. If you have, let's see, this is weight of board. It's coming down this way, rotation this way, and weight of woman is going to cause a rotation this way. Okay, so you have two rotations this way, or two torques moving in this clockwise direction. You have a counterclockwise direction over here. So we know that the torque exerted by this reaction force here is going to have to equal, right? I mean, the board's not moving. We're in static equilibrium. Is going to equal the torque of the board plus the torque of the woman. Okay? So let's go ahead and solve the torques. We know pretty much everything but the distance of the woman. So we can kind of move everything to one side, solving for those torques, and then finding the distance, just the end result. So let's do that now. These terms are going to move over. So you're going to have the reaction. We're going to subtract this. Torque of the board is going to equal the torque of the woman. Okay, let's solve for the torques now. So this is going to be the reaction force times that distance minus now the weight of the board here. So I should probably weight of the board, and the distance is just going to be the distance of the board divided by 2. It's going to equal, we have the weight of the woman, and we also have the center of gravity of the woman, which we are trying to find out. Okay, so I went ahead and carried over some of these values. We have the reaction force times the length of the board. After all, this is what we're dealing with, okay? So this complete length of the board here. And then opposing that direction is the weight of the board here. This is basically L over 2, right? It's coming from the center. So you have those. And then we have the weight of the woman, which if she's laying on the board, it's going to be about there. And this is going to be the distance of her center of gravity. But her weight comes down from that center of gravity. All right, so solving for this, we're going to move, after we calculate this, which is going to equal 339.5 foot-pounds. And it's okay if we stay in imperial units. In fact, just being a United States citizen, we know that a lot of units are in imperial units. It's just what we use. So it's fine to keep it in this. In fact, in industries, it's often used, at least in the US. So now we're going to divide by her weight, which is 120 pounds. Let's cancel units. Well, good. Now we can see we're on track to solve for her center of gravity, which happens to be 2.83 feet. There we go. It's as easy as that. I guess the only tricky part of this problem is just being able to recognize that the weight of the board is going to be factored in, and that length distance is half the distance, because that's where the weight is distributed from its center of gravity. So that's all to talking about center of gravity and the reaction board. I hope this helps your understanding in biomechanics conceptually with a little bit about torques and levers, and I hope this can help you move forward.